Most of the time when we talk about a line segment, we're referring to a segment such as AB, where we have point A and point B and the infinite number of points between those points. And that segment AB is just drawn on a plane. This type of segment can be found in plane geometry. Plane geometry refers to the fact that this segment is just drawn on a plane. In order to find the length, the measure of AB, we would need a ruler and the ruler postulate. Another type of geometry takes these points and places them in a structured order, such as P and Q. P is just not some random point. It's found at the ordered pair, -2, 5. And Q is just not placed anywhere. It's found at the ordered pair, 4, 1. In order to draw P, we need to go -2 in the x direction and 5 in the y direction. Now P isn't just some point on the plane, it's this point in this structured space. Q is at 4, 1. The segment PQ isn't written just anywhere in the plane, it's written right here in the plane. This type of geometry where we have structure and ordered pairs is called coordinate geometry. In order to find lengths in coordinate geometry, in order to find measures in coordinate geometry, we're going to need a formula. That formula we're going to need is the distance formula. In order to find the distance formula, we're going to turn PQ into a right triangle and then use the Pythagorean theorem. To find the length of this leg, the length of this leg is really the difference in our x values. This length is x2 minus x1. And this length is really the difference in the y values between P and Q. It's really y2 minus y1. Now if I were to use the Pythagorean theorem to find PQ, I would need to square this length and square this length and add those two measures together and then take the square root. In fact, that's exactly what the distance formula is. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. The distance formula is really the Pythagorean theorem. So to find the measure of segment PQ, we're going to use the distance formula. We're going to plug these values into this formula. If you forget the formula, you can always think back to this right triangle and the Pythagorean theorem. x2 minus x1, y2 minus y1. Order of operations says do what's inside of the parentheses first. I'm going to keep everything else the same. 4 minus -2 gives me +6. 1 minus 5 gives me -4. The next step in the order of operations, exponents and radicals. I'm going to take care of these two powers. 6 squared is 36. -4 squared. Be careful. if you use your calculator to do -4 squared, your calculator is going to tell you the right answer to the wrong problem. -4 squared is really -4 times -4, and a negative times a negative is a positive. If you type in this problem into your calculator, you're telling the calculator to take 4 squared, which is 16, and then take the opposite of that answer. We want -4 squared. Notice that I put parentheses on my calculator, just like there's parentheses in this problem. I don't get to get rid of the parentheses until I get rid of this squared. -4 squared is actually positive 16. (36 plus 16) and the square root of 52 is approximately 7.2. The measure of PQ is exactly the square root of 52 long, and it's approximately 7.2. When we're working with plane geometry, we use theorems and postulates. When we're working in coordinate geometry, we need formulas. We don't want to just take a ruler to measure PQ. Since this already is in a structured, ordered plane, we want to develop this formula to find the measure of PQ.